Right. So this is my seventh question on the problems of differentiation, or the applications of them rather. So you have got water is poured at a rate of 18 centimeters. Now, once I have something like that, I like to um, record what I know. I know that the volume versus the time is 18, and you can see that in the units because it's 18 cubic centimeters per second. So that is dv dt, because it says rate of change into a triangular prism, and it's 1 meters. All right, with equilateral triangle. So this is an equilateral triangle here. Okay, and also know that this is 1 meter all the way up to there. And since we are given our things in centimeters, perhaps it will be worthwhile also to record as 100 centimeters. Find the rate. So what we're supposed to find is find the rate of the height. So dh dt when the height is equal to 6 centimeters. So that's what we need to be able to find. The height with respect to the time. Okay, but there's a number of things that we need to be on the lookout for here. So basically, we also need to understand something. All right. So suppose the height is, our height is somewhere here. So we need to be able to find what the volume would be. All right, as water is poured in there. All right, so we need to find the volume of that in order for us to determine what we are dealing with. So let's just see. We have got a equilateral triangle. And once we have that equilateral triangle, let's say I call this the base, or B, and that will also be B. Okay. And another thing that we know that each of these angles will be 60 degrees, so that's 90 there. So in order for us to find the height, okay, that we are dealing with there, we need to come up with a formula there, right? So in order for us to find a formula, using our ratios, and this is very important, okay, we are going to say the sine of 60 degrees is equal to h over b, okay? So we are looking for h. So h over b, so we're going to make b the substitute formula. So b will be h divided by the sine of 60 degrees. All right, so let us just grab our calculator. Just want to show you something as far as the sine of 60 degrees is concerned. Sine of 60 degrees is nothing but, so this is h over root 3 over 2. So b becomes 2h over root 3. Very important that you get that concept. Now that we have that, we can actually find the area of the triangle because we know what the base would be. So the area of the triangle is a half times base times height. So the area would be 1/2, okay, times the base, and the base is 2h over root 3, and we multiply that by the height. So, well, this is going to clean up nicely to h squared over that. So this is the area of the triangle, okay? So in order for us to determine the volume, we are going to say the volume, therefore, is going to be the area of the triangle multiplied by 100, where 100 is the length, okay? So that gives us V equals to 100h squared over root 3. Now that we have the volume, we can actually differentiate with respect to the height. And if we do that, we'll have 200h over root 3. So we have got dvdh here. We also have got dvdt. Okay, dvdt. So we have dvdt, which was, I'm going to come back there. We have dvdh, we have dvdh, which is 200h over root 3. dvdt was 18 cubic centimeters per second. So that was 18. But what we need to calculate is we need to calculate dh/dt. So in order for us to find dh/dt, for example, so if you look nicely, dh/dt would be nothing but dv dt times dh dv. Okay, but if you look nicely at what we have, dh dv, we have the other way around here. We have this value, so this would be now the other way around. It will be now root 3, okay, because we're looking for dh dv, root 3 over 200h, and we multiply that by 18. So when we multiply that by 18, this is how we use the chain rule, so that we can go ahead and you can clean this up. All right, it's 18 root 3 over 200h. This is dh dt. But what we are looking for is we are looking for dh dt when h is equal to, what does the question ask us? Find when the rate of change of the height is 6 centimeters. So when h is equal to 6 centimeters, what will be the height versus the time in centimeters per second? So that would be 18 root 3 over 200. Now you substitute that with h is equal to 6, you substitute 6. Okay, so maybe we grab our calculators just to make sure we are on the right path. Okay, so it's going to be 18 root 3 over 200 times 6. So we get 0.025, more or less, give or take. We get 0. If we sponge that in, 0.02598, 0.02598 centimeters per second. Okay, or you can go ahead and you can even decide to simplify this one a little bit. Okay, you can say 6 goes there once, 6 goes there 3 times. Someone else can say 3 root 3 over 200, and that is centimeters per second. Well, all of these will be exactly the same. All right, so that's the rate of change of the height with respect to the time when the height is 6 seconds or 6 centimeters. Okay, so that's the rate at which the water will be poured in at that particular height. Okay, so again, look at the question. There are some trigonometry issues that you need to resolve in order for you to be able to solve this question, and then also look at what you are given. The rate, you're given the gradient, so dv dt, how do you know that is the volume, cubic centimeter per second, okay, divided by time. So if you look at the units, they also can guide you. Okay, so I hope that all these 7 questions that I have done have at least assisted you somehow with solving questions relating to finding or relating with the applications of differentiation.